In kinematics, we study the motion of bodies without considering the forces that cause the motion. Let us first understand what is meant by the position of a body. The position of a body in space is denoted by three coordinates: x, y, and z. The path length and displacement of a body depend on how its position changes with time. To specify the position of a body, we use a reference point with respect to a set of axes. The set of axes consists of three mutually perpendicular lines labeled as the x, y, and z axis. The point of intersection of these three axes is called the origin. The origin is used as the reference point for the body. To specify the position of a body, its x, y, and z coordinates are given with respect to this rectangular coordinate system. A stopwatch is included to complete the frame of reference. When any one or more of the coordinates change with time, the body is said to be in motion with respect to the frame of reference. The motion of a body with respect to the frame of reference could be parallel to the x-axis, parallel to the y-axis, parallel to the z-axis. In the xy plane, in the xz plane, in the zy plane, or in space. When the coordinates don't change with time, the body is said to be at rest with respect to the frame of reference. Rest and motion are relative terms and are always specified with respect to the frame of reference. A simple example of a car moving on a straight road will make this concept clear. Suppose you take a frame of reference with a fixed point on the road as the origin. We say that the car is moving. However, when you take a person sitting in the car as the origin of the frame of reference, then the driver of the car is at rest, as, in this case, the frame of reference itself is moving along with the car. If the body has one-dimensional motion, then we consider only one axis of reference. It is either the x-axis or the y-axis. This type of motion in a straight line is known as rectilinear motion. If the body is moving in a plane, then we consider any two of the three reference axes. If the body is moving in space, which is three-dimensional, then we have to consider all the three reference axes. Let us examine rectilinear motion more closely. To study the motion of a body along a straight line, we have to align the straight line along one of the axes, which is usually either the x-axis or the y-axis, and then choose a convenient origin, O. Positions to the right of O are taken as positive, and to the left of O as negative. Positions above O are taken as positive, and below O as negative. With time, the position of the body changes and describes a path. Let's consider the example of a man walking along a straight line. Take the x-axis to coincide with the straight line. Fix the origin of the axis at the point from where the man starts walking. This is represented by x is equal to 0 when time t is equal to 0. A and B represent the position of the man at different instances of time. In the first instance, the man moves from O to A. The distance moved by him is OA, which is 36 meters. This distance is the path length traversed by the man. In the second instance, the man moves from O to A and then moves back from A to B. The distance between points A and B is 12 meters. Now, the path length traversed by the man is OA plus AB equal to 36 meter plus 12 meter is equal to 48 meter. The path length is a scalar quantity as it has only magnitude and no direction. Path length is the distance traversed by a body, whereas displacement is the change in the position of the body. Let us consider an example to understand displacement better. Let an object be placed at point O, which is the origin. Let x1 and x2 be the positions of an object at time t1 and t2. Its displacement delta x in time delta t is equal to t2 minus t1 is given by the difference between the final and initial positions. Delta x is equal to x2 minus x1. When x2 is greater than x1, delta x is positive. And when x2 is less than x1, delta x is negative. A positive sign indicates displacement to the right side. A negative sign indicates displacement to the left side. Since displacement has magnitude and direction, it is a vector. For example, let's consider the displacement of the man moving from O to A. Distance delta x is the difference between the initial point and the final point, which is equal to 36 meters. The displacement of the man in moving from A to B is delta x, where delta x is the difference between 24 meters and 36 meters, which is equal to minus 12 meters. The magnitude of displacement and the path length traversed by an object may or may not be the same. For the motion of the man from O to A, the path length is 36 meter, and the magnitude of the displacement is also 36 meter. For the motion of the man from O to A and back to B, the path length is 48 meter, whereas the magnitude of the displacement is 24 meter. There may be cases where the displacement of an object may be zero, even though it has moved, but its path length will not be zero. For example, the man starts from O, goes to A, and comes back to O. The final and initial position of the man being the same, his displacement is zero. However, the path length of his journey is 72 meters. Let us observe some types of motion and the corresponding graphical representation. Case 1. When an object is stationary, its position does not change with time. A car is stationary, say, at a point 40 meters from the origin. The graph will be a horizontal line passing through the 40-meter mark on the y-axis. Case 2. If the car starts at point 0 and covers equal distances in equal intervals of time along a straight line, the graph will be an inclined line. When a body covers equal distances in equal intervals of time along a straight line, it is said to be in uniform motion. Case 3. If the car starts from the position of rest, picks up speed and moves with uniform speed for some time, later the brakes are applied and its speed gradually decreases, and the car finally comes to rest, this graphical representation shows all the 3 types of motion. That is, acceleration, uniform motion, retardation, and back to rest.